All right, let's look at the homework 4.3, problem number 2. All right, the graph of the first derivative, so f prime of a function is given here. Then we try to answer the following questions. All right, so part A, on what intervals is f increasing? Right, so we want f to be increasing, so we look at the derivative and make sure that the derivative is positive. So when it's positive, the graph stays above the x-axis. So you can see that between 2 and 3. So you can see that between 2 and 4, you can see that the graph is above the x-axis. So I would say 2 to 4. And what else? Let's see, from here 6 to 9. The graph of the f prime is above the x-axis. So we'll take that. And part B. What values of x does the f local maximum? All right. So we look for the critical numbers. Let's see. Critical number is going to be here. So it, derivative becomes 0 there, and derivative becomes 0 there, and derivative becomes 0 there. All right. Then in order to have a local maximum, so it has to change, the derivative has to change from positive to negatives, because you have to get a hill. All right. So then if you look at the sign of this critical number sign change, the derivative is coming from below the x-axis then above. So it goes from negative value to positive value. So that's going to be a local minimum there. And by here, it's changed from positive to negative. So it looks like at 4, you're going to have a local maximum. And the next one is, let's say this is again negative to positive, so it's going to be a local minimum there. All right, so that's answer for part B. All right, and actually, second part is what value of x has a local minimum? So you can see that it's going to be 2 and 6. So you have 2 and 6 using the first derivative test. All right, part C. Well, what intervals is f concave upward? Right. So in order to have a concave upward picture, derivative has to be increasing, because the second derivative is positive, means the first derivative is increasing. So you can see that the graph is increasing here from 1 to 3. And also 5 to 7, and then you have 8 to 9. Right, so answer is going to be from 1 to 3, and 5 to 7, and 8 to 9. All right, and on what interval f is concave downward? So everywhere else, so it looks like it's going to be from 0 to 1, and 3 to 5, and 7 to 8. Right, and part D, what are the x-coordinate of the inflection point? Right, so we have to see a concavity change. Right, so concavity change is happening. Right, so we know that here, right, concavity, so it's a concave down here, concave down, because the derivative is decreasing, and this is concave upward. So you can see that at 1, you're going to have an inflection point. Right, so at 1. Right, and here concave up to concave downward. So at 2, at 3, you're going to have an inflection point. And concave down to concave upwards. So at 5, also you're going to have an inflection point. Right? And here, and the concave downward here, so at 7, you're going to have another inflection point, and here, and concave down to concave upward, so at 8, you're going to have an inflection point as well. All right, that's it. I hope that this was clear.